Hi and Assalamualaikum madam. My name is Muhammad Eman Haikabi Mansur. So today I would like to answer this question. So the question is, what is differentiation? So basically, differentiation is the mathematical tools need to find the exact slope of a tangent line at a single point on a curve. By using a limit, we like to separate points on a curve closer and closer together until distance between them shrink to zero. At this exact limit, the line connecting them stabilizes into a tangent line that perfectly grazes the curve, revealing the instantaneous rate of change at the precise spot. So here we can see the definition of differentiation. So the definition of differentiation is lim h approaching to 0 f of x plus h minus f of x over h. So we move to the next slide. So next, we move to the techniques of differentiation. Basically, differentiation have 4 techniques. We have power rules, product rules, quotient rules, and we have chain rule. So we move to the first one. The first one is power rule. So power rule, how to use? If f and g are differentiable at x, then so are f plus minus g and d over dx. F of x plus minus g of x equal to d over dx. F of x plus minus d over dx. G of x equal to f prime of x plus minus g prime of x. So basically, here some of our rule. The next one is product rule. So product rule, if f of x equal to u of x, so we move to the second one, product rule. So product rule, if f of x equal to u of x multiplied by v of x, where u of x and v of x are differentiable at x, then f prime of x equal to u of x v of x plus v of x u prime of x, or we can use dy over dx equal to u v prime plus vu prime. So there for the product rule. So the third one is quotient rule. So how to use quotient rule? Quotient rule, if y equal to f of x equal to u of x over v of x, where u of x and v of x are differentiable at x and v of x not equal to 0, then f prime of x equal to v of x u prime of x minus u of x v prime of x over, in bracket, so the third one is the quotient rule. So the quotient rule, if y equal to f of x equal to u of x over v of x, where u of x and v of x are differentiable at x and v of x not equal to 0, then f prime of x equal to v of x u prime of x minus u of x v prime of x over v of x square, or we can use dy over dx equal to vu prime minus uv prime over v square. So that's for quotient rule. So the last one is we have the chain rule. So in this section we will discuss different So the last one is the chain rule. So how to use chain rule is, If u is differentiable at a point x and y is differentiable at a point u, the chain rule says that dy over dx equal to dy over du multiplied by du over dx. This is called Leibniz notation. So that's all for the technique of different. So that's all for the technique of differentiation. So we move to my friend Kiss. Okay, thank you.
Assalamualaikum and hi, my name is Christina Bentin Ijami, and today we are going to solve a differentiation problem. So for this question, find dy over dx for the following function. So a, y equal to x squared cos 4x plus 1. So for this function consists of two terms multiplied together, which is x squared and cos 4x plus 1. So because of they are multiplied, we must use the product rule. So here the product rule formula is dy over dx equal to uv prime plus vu prime. So for the first step, we need to identify the u and v. u and v. U is x squared and v is cos 4x plus 1. Next, we need to find u prime and v prime. We differentiate of we differentiate x squared, we got 2x, and for v we need to use chain rule. First, differentiate the outside, the derivative of course is negative sign, and we copy back the inside for x plus 1, and then multiply it by the derivative, the inside function for x plus 1, which is 4. So we got negative 4 sign, and we copy back for x plus 1. And then after we got all the information, we insert it into the formula. So we got dy over dx x squared negative 4 sine 4x plus 1 plus cos 4x plus 1 and 2x. After that, we need to simplify this equation, and we can get negative 4 square sine 4x plus 1 plus 2x cos 4x plus 1, and this will be our final answer. Hi, welcome back with me, Nina Christina, and now let's move on to part B. Y equal to ln x squared minus 1 over x power of 3. So here we have a function in form of fraction. So since this involves division, we need to apply quotient rule. So here the quotient rule, or the formula of quotient rule, is dy over dx equal to vu prime minus uv prime over v squared. So first step, we need to identify the u and v. So the numerator is our u and denominator is our v. So our u is ln x squared minus 1. Our v is x power of 3. So we need to find u prime and v prime. V prime, we got 3x squared. And for u, to differentiate ln x squared minus 1, the rule is 1 over the inside function. And then we multiply by the derivative of the inside function. So 1 over x squared minus 1, and we multiply with 2x. So we got 2x x over x squared minus 1. So when we got all the information, we need to substitute into the formula. So into this formula, and we got dy over dx equal to x power of 3 2x over x squared minus 1 minus ln x squared minus 1 and multiply with 3x squared and over x power of 3 square. And next step, we need to simplify this equation. So we got 2x power of 4 x square minus 1 minus 3x square ln x square minus 1 over x power of 6. So we can factor out x square, so we can cancel it out with the x square at the bottom. So 2x square so x square, so 2x square x minus 1 and then 3 ln x square minus 1, so over x square. So we can cancel out. So we got 2x square x square minus 1 minus 3 ln x square minus 1 and over x power of 4. So final step is we need to write this fraction as a single fraction. So dy over dx 2x square minus 3x square minus 1 ln x square minus 1 over 4 x power of 4 and x square minus 1. So this will be our final answer.
Hi, good evening, everyone. My name is Muhammad from Libya, and today we will be answering the third question from the second assessment of MA1. The question is given y square plus sine x square plus y equals to 5. Find dy over dx using implicit differentiation. So for the first term, we will use which is which is we will let u equals to x and the y square, which we will use let y equals to y square. And we will differentiate u to the respect of x, which we will get 1. And v to the respect of x, which we will get dou y dy dy over dx. And we will do some cross multiplication, and we will get x 2y dy over dx plus y square in bracket of 1. And we will complete the multiplication and do some expansion, which we will get 2xy dy over dx plus y square. And for the second term, we will use chain rule, which is we will differentiate sign first and differentiate the inside the bracket later on, which is when we differentiate sign, we will get cosine, which is cos x square plus y. And then when we differentiate the term inside the bracket, and we will get 2x plus dy over dx. And we will combine this into one equation. And for the constant rule, which means when we differentiate 5 to the respect of x, and we will get 0. So let's combine these terms into our equation, which is this is what will happen next, which we will combine the first term and the second term and the third term into our equation, and we will expand this into their respective algebraic terms, which will give us 2xy dy over dx plus y square plus 2x cosine x square plus y plus dy over dx cos x square plus y equals to 0. And for the next step, which we will gather the terms with containing dy over dx in the left hand side, and the terms without containing them in the right hand side, which will give us 2xy dy over dx plus dy over dx cosine x square plus y equals to, and the terms without containing it, we will move it to the right hand side, which will give us negative y square minus 2x cosine x square plus y. And for the next step, which we will factorize this into one algebraic terms, and which will give us dy over dx 2xy plus cos bracket x square plus y. And we will copy the right hand side, which will give us y square minus 2x cos x square plus y. And finally, for the last step, we will notice that this term and this term are multiplied together, which when we move this to the right hand side, it will become a division like this, like shown as below, which is dy over dx negative y square minus 2x cosine x square plus y over 2xy plus cos x square plus y. And this is our final answer. Thank you for listening, and goodbye. Thank you.
Okay, for the fourth question is, use linear approximation to estimate the value of cube root 8.002 minus 8.002 cube. Correct to 4 decimal places. So for this question, we have 5 steps. So the first step is we need to identify effects. So how to identify effects? We need to change, or we need to replace this with x and this also with x. Yeah, like that. So we get fx equal to cube root x minus x cube. So we get this, and then That's 1 over 3 minus 3. So we settle for the first step. So we move to the next step is differentiate fx to compute f prime x. So we need to differentiate. So differentiate is f, so 1 over 3 x minus 2 over 3 minus 3x square equal to, then we simplify that. No, sorry. Okay, next 1 over 1 over sorry 1 over 3 bracket cube root x square minus 3x square. So we settle for the second step. So the third step is we need to determine value of x and x naught. So how to determine it is we just write the formula. Delta x equal to x minus x naught. So what is the x naught? X naught is the convenient starting point. X naught is 8. So we write here x naught equal to 8 and x equal to 8.002. So yes, is this and sorry 8.002 minus 8, and what we get 0.002. So we move to the next step. So the first step is we need to compute value of f as naught and f prime as naught. So sorry, f x naught equal to, yeah, here 8 minus 8 cube equal to 2 minus 5.2. So we get 150, 5.0. Okay, sorry. Hi and Assalamualaikum madam. My name is MAT183. So today I would like to answer this question. So the question is, what is differentiation? So basically, differentiation is the mathematical tools need to find the exact slope of a tangent line at a single point on a curve by using a limit. It's like to separate points on a curve closer and closer together until distance between them shrink to zero. At this exact limit, the line connecting them stabilizes into a tangent line that perfectly grazes the curve, revealing the instantaneous rate of change at the precise spot. So here we can see the definition of differentiation. So the definition of differentiation is lim h approaching to 0 f of x plus h minus f of x over h. So we move to the next slide.